In this video, we're looking at BMAT 2020, Section 2, Question 27. So, we're told a bar magnet rotates with 120 revolutions per minute in a coil of wire which induces a voltage across the coil, and we have to work out which statements are correct. So, our first one is that increasing the turns in the coil will increase the max value and the frequency of the voltage. So, is this true? How is increasing the coil of wire, the number of coils, going to change the voltage? Well, if we think about it, if we increase the number of coils, that's increasing the number of times the magnetic field is cut, so it will increase the voltage. However, it's not going to have any effect on the frequency. That's going to depend on things such as the speed of the rotation, which we're not told changes, so this is incorrect. Our second statement is that the direction of the induced voltage reverses every 0.25 seconds. So, we know that in the question we're told that the bar magnet rotates 120 times per minute. So can we work out how long it's going to take for one revolution? Well, if we divide by 60, we know that's 2 revolutions a second, or 1 revolution per half second. And this is going to be our indicator of the direction of the induced voltage. So if we draw out how our bar magnet is going to rotate, it's going to start off maybe in one position, it's going to twist around and then again and then again. So this is going to show 1 revolution. But how does the voltage change during this rotation? Well, let's say we're going to start off here and this gives us a positive voltage. How is that going to change when our magnet rotates? Well, as we can see here, none of the poles are up or down, so we're not going to induce any voltage. It's going to be 0. If we twist it around again, that's going to be the opposite to this first one, so it'll be negative, and then we're going to finish off again being 0. So how many times does the induced voltage direction change? Well, we can see it changes twice per revolution. And since we're doing that in half a second, that means we need to half this to get how many times the direction changes, so that will be 0.25 seconds. That is correct. Our third statement is that there's always an induced current in a conductor experiencing a change in magnetic field. So is this true? Will we always have a current? Well, if we have a complete circuit that's been created, then yeah, a current will flow. However, if there's not a closed circuit, there is no way a current can flow around that, so that is incorrect, even if the component is experiencing a changing magnetic field. So although it can do, not always, so this is incorrect. And that means our final answer is C.